Okay, here's a quick walkthrough of the RPM from Quintessential Universal Building Devices. The RPM, first impressions, very, very well constructed, very rigid frame. Shouldn't have any issues milling with the 1 horsepower milling package that you can get with it. And as far as 3D printing, it's just plain overkill. It's a very well assembled machine. But a couple of things that you need to do to make sure that things are calibrated and functioning properly. Once you get the device, after running it for about 4 or 5 hours, there's going to be some initial break-in on the belts. So they're going to stretch just a little bit after that first 4 or 5 hours. After that, they should not stretch anymore. And because of that stretch, what you're going to want to do is tighten up the belt up here on top that's driving the Z-axis. So what you need to do here is take the Z-axis and drive it all the way to the bottom of the machine so that you basically have metal on metal contact. Then what you can do is loosen up these tensioners. Initially it should have 2 tensioners on it. What you're going to wind up doing is installing a 3rd tensioner here to help take up some of the slack. But what you can do right now is you can loosen up the tensioners that are there and remove the Z-belt from all 4 of the screws. Once you have that done, you can just kind of finger tune the tops of these screws to make sure that all 4 corners of the Z-axis have that metal-to-metal contact. Then what you're going to want to do is loosen up the set screws on the gears that drive the top of the Z-axis linear screw system. Once you've done that, you can put the belt back around those gears. You can set up the tensioners. You may need to add that 3rd tensioner in order to take up the slack from that initial break-in period. And once you have the belt properly tensioned, now you can tighten up the screws on the Z driver gears. The reason for going through this is that you really want to make sure that all 4 of those gears on top of the Z system are fully meshed with the belt. That's why you're going to loosen up the pulleys, the gears on the top, and make sure that you get the belts fully engaged before you tighten everything back up. So just make sure all those set screws are tight, and you should be fine for adjusting the Z-axes. If you don't really move the machine, probably never need to do that again. Occasionally, if you do a lot of use with it, a set screw might loosen up. You can take care of this by putting some Loctite on those set screws. I'm really not a fan of Loctite, so I don't mind every few weeks to a month checking to make sure that those gears are fine, and maybe just tightening the set screws a little bit to make sure that the Z-axis is fine. Now, the Y-axis. The Y-axis is driven by 2 big NEMA 23 motors. And on occasion, the belts here will loosen up. And one of the main signs of any of the belts being loose on the system is that it will get particularly noisy. So on the Y system, it's really easy to fix this, to tighten up the belt. If you look at the Y motors here, you'll notice that there's 2 screws at the bottom of the motor. All you have to do is loosen those screws out, pull the motor out to tighten the belt, and tighten the screws down while you've got the belt under tension. That's all there is. About a 20 or 30 second little maneuver, very quick and easy. Might be difficult to see, but you have a similar setup on the X-axis motor. Now, if you're assembling this, or if you think things aren't quite right, the main tuning things on the RPM are to make sure that everything is parallel and square. So that's the point of tuning the Z-axis, is making sure that that whole gantry system is moving up and down and absolutely level. The other thing you want to do is make sure that the X-axis is perfectly perpendicular to both of the Y-axis screws. And the way that you can do this is pretty simple. You also need to make sure that the Y-axes are perfectly parallel with one another. You can see that there's a couple of screws on the top of the Y-axes. You can use these for adjusting making adjustments to make sure that the X-axis is perpendicular to both of the Y-axes. So all in all, not that difficult. Might be a learning experience the first couple of times, but pretty straightforward to tune and calibrate. So that's the walkthrough of the RPM. One other thing that I do want to mention about the RPM is that it is important to make sure that the screws and linear rods stay lubricated. They are made out of steel, so they are subject to corrosion. Should not be an issue at all as long as you keep them lightly lubricated. Using something like a nice silicone grease and just lightly coat them every couple of months, and you should have a long and happy life with your RPM.